ES51. Here's Hall.
So far away, down the hills and round the bend.
Aqua and the engineers. Yet another sunny morning in Pierce. The tennis balls are singing, the Velcro is ringing, and the pipe ramp stands majestically in the center of the island as usual.
I do like to wiggle some wheels.
Wait, who's that? Oh, it's Aqua, the cutting edge of American innovation. Good morning, Aqua.
Good morning, narrator.
Chop chop, today's your big day, said the Fat Controller. The engineers have a very important task for you.
Always wear safety goggles, kids. Your task is actually very simple. You pick up balls from the playing field using your elevator, you bring out the ramp, and you fix it to the wall. Going up the pipe ramp gives you extra points, as do special configurations on the board.
We considered a rocker bogie system for going up the pipe ramp, but we chose a more conventional design instead. We also originally intended to use a scoop, but we used an elevator instead. We manufactured our robot using state-of-the-art processes like laser cutting, 3D printing, milling, and chilling. We laser cut the chassis, wheels, and most of the elevator, and we turned hex shafts on the lathe to create our axles. We also 3D printed the pulley spool and used the drill extensively.
We opted for a back-wheel drive system with a gear ratio of 12. Although this makes our robot slower than the others, we have far more torque to charge up the ramps. The chassis is approximately 3.5 inches off the ground to provide enough clearance for going up the pipe ramp. Unfortunately, it turns out that our center of gravity is too far to the back because our motors are in the back, so we'll have to go up the pipe ramp backwards using belts if we want to get up it at all.
The elevator system is designed to lift balls directly and carry them safely up to the wall. Once on the wall, the elevator's roof raises the ball to the top, as the top row is taller than the 12 inches in height allowed. We need a lot of torque for this, so we geared up our pulley servo as well.
The triangular frame provides extra support to the elevator system so it stays straight despite the heavy load. The carriage has little wheelets that run along guided rails to ensure that it doesn't jam. The bottoms of the rails are tapered so the carriage can easily re-enter the rails from the bottom as needed to reach the ground.
Some interesting things we learned throughout the process were that planning and designing is just as important, or more important, than building the robot.
And tolerancing the right dimensions is important, knowing what needs to be precise and when to do so. We learned how to go through the troubleshooting process efficiently and locate problem areas.
During the seating trial, our robot worked as expected. Our inexperience with driving cost us quite some time, but with more practice, we're confident that we're going to mill and chill.
Trust me, I'm an engineer!
I feel much more confident about my task now. I'm off to mill and chill.
Mill and chill!
Where American innovation meets American ingenuity.